Hi everyone, I hope you're having a great start to Future Build. So we're here today to talk to you about materials, exciting and innovative materials that can feed into creating healthier, more regenerative and more inspiring buildings and spaces. As architects, designers, engineers, specifiers and manufacturers of materials, this knowledge of materials is going to become an invaluable toolkit. Understanding how materials behave, where they're sourced from, what their end of life looks like, and indeed the impact that they have on both human beings and the environment is going to become more and more crucial. So today, we're going to cover a couple of key concepts and a lot of important trends with you. And we're also going to give you a bit of a hands-on materials experience. We've got a giant stack of materials from our library here. We'll try and hold them up as we talk about them on screen. And if time permits, we'd love to have you all come over at the end of the session and kind of have a touch and feel for the materials themselves. All right, so who are we? We're material driven. I'm Purva.
I'm Adele.
Adele. Um, and we're a design consultancy and materials library based here in London. All of our efforts, whether it's commercial or educational projects that we do, center around innovative materials and the entities behind them. This can be individual makers or large-scale manufacturers. Through our work, we try and pair the developers of innovative materials with strategic projects and applications. We tend to play the role of knowledge experts, curators, agents, and even project managers. So this is a snapshot of our materials library. It's currently based at the Building Center, who we're very fortunate to have entered into a partnership with, and we were able to make this materials library a publicly accessible resource. The library serves as a basis for much of our work as a consultancy, and we regularly update this library with innovative material samples from manufacturers and individual designers. Another thing that we try and do in this library is have larger scale installations. So if you were to visit, you'd see a material as flooring, as a wall panel, or as a piece of furniture so that you can actually see what it looks like in situ. Another thing we try and test out in this library is new ways of displaying and categorizing materials, something that we're learning these days. And at the same time, better ways of narrating the stories behind these products. Finally, our library is an inspiration space, but it's also a gallery where you could directly specify products from. So just to continue and kind of wrap up on what it is that we are and what we do, this is the type of projects that we tend to work with. On the left, you'll see our role as curators and exhibition designers. This is a really fun project that we did for the Baltic Center in Newcastle. It was a geodesic dome of a really, really large geodesic dome of materials created for the Great Exhibition of the North. We had the pleasure of working with almost 50 designers and manufacturers, each of whom supplied these massive triangles of materials, and they all represented Northern identity and innovation. In the center, similar to the experience we're all having right now, the talks and workshops that we do, this is us doing a biomaterials workshop at the Design Museum in London. And finally, on the right, the kind of work that we do with larger brands and entities. We recently worked with the Woolmark company, who launched an interesting campaign called the Woolmark Performance Challenge last year with Adidas. And not only did we support the campaign through workshops and talks, we helped them create a trophy for the winners with a very interesting material. It's actually made with a material called chips board, a take on chipboard. We'll have a chance to talk about it more ahead. But we're helping them turn these tangible ideas about the competition into the trophy design as well. So one of the things that we're seeing through our work, obviously, we get to interact with various industries, is that there's an appetite for innovative materials across many, many sectors, from interior design to packaging. We're seeing many, many industries start to blur together, and there's an interest in both creating and consuming materials across these industries. As you can see in this image right here, this is an exhibition that we recently did for Architect at Work. It was called Future Proof, and we brought together material samples from packaging design, from fashion, textiles, architecture, construction. We touched upon topics like energy efficiency, health and well-being, etc. So we really find that the world of materials is super interdisciplinary.
So as you can see, our work brings us in contact with a wide range of materials, applications, sources, and professionals. This allows us to observe and to understand material trends and material needs that are becoming more and more relevant nowadays. In this slide, we list some of the key takeaways of the current landscape of material development and innovation. But we want to point out some of the ones that we consider more important. Themes, for example, such as bio-based materials, where designers are co-creating with nature to create these exciting new materials. We're also looking at materials that have a huge heritage component. Those are materials that have a powerful story behind them and that connect us to our cultures and our communities. We're also going to look at materials that enhance health and well-being, and also materials that are regenerative. These are materials that are actively playing a role in adding to our environment. They're helping us heal the damage we've already created in our planet. And here we have a great example of waste-based materials. So beyond our typical idea of waste that could be plastic, glass, or paper, we're also looking at new sources of waste. For example, dust. In this project called Dust Matters by Lucy Libot, she has created a glaze using dust particles. So the power of materials is becoming more and more relevant. We're recognizing this more and more. So entities such as the New Materials Award based in the Netherlands is becoming more and more relevant. This award looks to recognize and support makers, innovators, and designers who are pushing boundaries of their industries, whether it's science or design, supporting us in creating new solutions for our future. This award sits at the crossroads between art and science, design and technology. This is a great example that you see up here, Shahar Levin and her project Lithoplast. We have a sample here. She was one of the shortlisted designers last year. And this is an experimental project that she creates an experimental composite material. And she's looking at the idea and researching the possibility that in the future, plastic might be a material that is rare and that we're going to have to mine it. And we'll be creating this composite with other industrial waste byproducts such as dust or stone. So the material maker is the entity that is pushing us at the heart of this innovation and awareness of what materials are. But who is the material maker? The material maker can take on different shapes or forms. It can be a solo maker working alone in the studio. It could also be a larger manufacturer that is looking past its traditional material and trying to innovate. And it also can be a collaboration. The collaboration can be between a solo maker and an industrial manufacturer, or for example, it can be academia with a manufacturer. There's a whole range of possibilities. This is an exciting example. Diana Scherer, she's a solo material maker. We have a sample here, and she's creating exciting textiles by growing roots into different patterns. So for us, for material driven, what is a material maker? For us, a material maker asks better questions to support the development of our society. But more than that, it also asks, they come up with better solutions, but they ask better questions as well of what we're doing and the roles the direction we're taking in solving our problems. A material maker brings together the aesthetics of design, the functionality of science, and the heritage of our culture. A material maker is multidisciplinary and strategic. But that's our definition. We wanted to put up a quote from a material maker as well. Tom Meads is a material maker that is actually here today as well. He is the founder of Gami Design. He creates this beautiful circular speakers by recycling LDPE plastic. And for Tom Meads, a material maker, what's important about it is that he breaks free from the constraints of design. And it goes through a conceptual stage where he can kind of think out of the box and come up with crazy ideas. And then he takes those conceptual ideas and puts them into practice through material making. And it's through the experiments and the mistakes that they make that they learn about the potential and the limitations of a material.
So one thing that we're all finding out today is that there is no university agreed upon definition of sustainability. It means so many different things to so many different people across sectors. But one of the things that everyone seems to agree upon is that it is about reducing our footprint on the environment and meeting the needs of the present without compromising the future. These ideas of sustainability that we all seem to agree on are largely concerned with preventing damage or reducing the negative impact on the environment. But there is a really strong school of thought today that's saying that these ideas are outdated, that it's basically taking us only to the point of being neutral, but we need to move to a point of being positive. So true sustainability is about being regenerative and restorative and placing us in the positive. Keeping in mind this idea of positivity, taking us taking us beyond the neutral and into positivity and sustainability from this new perspective, we're going to list some criteria or some values that come to mind when it comes to material innovation. We're all very well versed with the concept of the linear economy and the scale of waste that it has generated for us globally. The circular economy and the new concepts that it's bringing to us is particularly relevant to the world of materials because it is suggesting that the waste of one industry can become the raw material for new material making. In the realm of challenging waste, say we think about topics such as sanitation, the idea of closing the loop is even more relevant because with attitudes that we've had in the past for recycling materials like paper, metal, and plastic, if we apply that same attitude to challenging wastes like urine, we have a better chance at solving problems such as sanitation. We thought this was a great example of a material, a beautiful material created from a very challenging waste. This is a designer called Sinae Kim. She uses urine to glaze her ceramic tiles in vessels. And not only does she create a really, I would say, really aesthetically pleasing glaze, she's also pointing to a historic past that we all have, where urine was used for medicinal purposes, for tanning. So this isn't a new concept. This is something that we've all been familiar with as a civilization. So she calls back that history. To us, the ideas of sustainability is really tied to end of life. And what does that mean? It means ensuring that the disassembly and degradation of these materials will be as easy as possible and will not leave any harmful residue. In an ideal scenario, a really good end of life means that materials can become the resource for a secondary production and the feedstock for new material making. Now, this is the case with Mogu tiles. This is a scalable product that is, it's an interior wall tile that is being used in architectural projects right now. It's a mycelium-based tile. It's created with natural waste as its substrate, on top of which mycelium, which is the vegetative root of mushrooms, is grown to create this very strong material. The good news about this tile, the way it works is it can be composted with other organic waste, and it can also be used as a feedstock for a secondary round of production of these mycelium tiles. I don't know how many of you know this, but mycelium doesn't just feed on natural waste, it can also feed on synthetic waste, which means all that plastic waste that we're sending to landfill, it could actually be digested by mycelium as well. So some really interesting possibilities. Maybe in the future these tiles will be grown on a synthetic landfill-based substrate. So we see an immense potential in redefining the elements that are considered staple to the building and construction industry. Timber, cement, bricks, metal. These are the materials that are used in the largest volumes across the globe in projects of all sizes. If we manage to improve the efficiency and behavior of these materials, we stand to create a really tremendous impact. We love this example of Biomason. This is a company based in the US. They're trying to relook at masonry, and their goal is to eliminate the carbon dioxide emissions that are normally associated with firing bricks. The way they do this is that they inject a bacteria between the aggregate grains, the mixture that's used to create bricks, and the bacteria produces a biocement which actually binds the brick together. So there's no need for firing, and it eliminates the carbon dioxide emissions that would normally take place. So really an interesting forward-looking perspective on brick making. Now, materials that have an ethical sourcing and production and a positive impact on all living things and the environment, that represents a strong strand of sustainability for us. We love this material. It's called Malai. It is being produced, I would say, pretty much at scale in India and Kerala right now. It's a vegan leather. It's approved by PETA, and it's created it's an animal-free material, so it's created with bacterial cellulose, and the bacterial cellulose is grown on coconut harvest waste. So I don't know if you guys know this, when you harvest coconuts for cream or for coconut water, there is an acidic residue that's left at the bottom of each coconut. If this waste was leached into fields, it actually causes immense damage to soils. So this company has found a way to take that acidic residue and use it to harvest bacterial cellulose and then convert it into a wonderful leather-like material like this. The material can be used for upholstery, for furniture, for bags, for shoes. It's really a very versatile material, and the production is scaling up a lot using machinery that was associated with rubber making.
So we've mentioned well-being before, but well-being is a huge part of being sustainable. So increasing rates of urbanization are leading to a great disconnect from the natural world. So it's very important and evident that we need to create new spaces where we can reconnect to nature. Direct or indirect elements of nature actually enhance our well-being, and it lowers the stress levels, our blood pressure, and our heart rates. And it actually increases productivity and creativity. So companies like Organoid, and we've got some samples here, do a great job at creating a natural environment inside. It brings the outdoors indoors by bringing these elements from nature, whether it's plants, seeds, flowers, little branches. What they do is they hardly modify the material. They just put a little bit of bioresin in it. So you actually have almost you recognize the material, and you can feel the fragrance, and you can actually touch it and feel the material. So it really does create an enhanced sense of well-being as you bring in the outdoors indoors. And then there's heritage, which you've also mentioned. For us, heritage is an extremely powerful message in sustainability. For Connor Taylor, the founder of Foreso, that sustainability is very important. What's important of sustainability is the provenance of the material and the narrative behind that material. For him, terrazzo is very tied to his childhood and how he grew up in the city of London with his grandmother. So through his terrazzo tiles, he wants to tell that story and explore what it meant to him to grow up with his grandmother in the city. The idea is that through these materials, you can also create a link, and then you can tell those stories on to future generations. What's also interesting is that the wood chips that are in that terrazzo, actually, a lot of them come from the pruning of trees in streets of London, so you can actually tell you what street that wood came from, tying you further into the community. And then there's transparency. Without transparency, we do not know what goes into the making of our products. Now, not only is this important because we need to know if there's something harmful in what we're wearing or what we put our food into, but it's important because we need to know the value of the materials that go into our products. We can achieve material transparency by pushing material manufacturers to disclose the environmental, the health, and social impact of the materials in their products. This can be achieved by third-party verification certifications, such as Cradle to Cradle or Declare, or also by self-disclosure tools like Portico by Google. By pushing manufacturers to disclose all this information, architects and designers can have more data to make better informed decisions about the products that they put into about the materials they put into their products. And then there's community. We mentioned before the idea of regenerative environment, where we talked about designers co-working with nature to produce better materials. But it's not only nature that we need to work with, it's amongst ourselves, it's across industries. We need to all collaborate and come together to solve these issues. There's a great example in Denmark where over 400 companies have already signed on to the Dutch Resource Agreement. And they declare that by 2030, 50% of the resources they use are going to be non-virgin. And by 2050, it's going to be 100%. Now, that's not an easy feat to achieve. So there's platforms like the Excess Material Exchange, who will be speaking here as well. They're supporting these companies in achieving these results by putting them together, creating a community where they can share their resources and their knowledge and difficulties. So we've been talking about the material makers, and we've talked about the different themes within sustainability. These themes like heritage, community, transparency, all of these motivate the material makers to come up with better solutions. So we're going to have a look at some of these, the results of these explorations.
So the architecture, building, construction industry is one of the most polluting industries in the world. It contributes to 23% of our air pollution and almost 50% of our landfill waste, which means this industry is so ripe for constantly re-looking at products and finding better and better solutions. So we love this project by Local Works Studio. Actually, Ben from Local Works is right at the back. If you have a question about this project, do ask him. What we love about this project is it's a material called they're oyster tiles, and these are created from oyster shells, so oyster shell waste. They do have two types of tiles, one which is just ground oyster shells, and another where the oyster shells are combined with demolition waste as well. And I think the detailing is really key here. It isn't just about the tiles themselves, because we are seeing other products working with waste. They found a way that the mortar itself for these tiles, these facade-mounted tiles, comes from the waste itself. So Local Works uses the oyster shells, grinds them up, and the calcination process and the firing process reveals a mortar. Incidentally, that mortar not only makes this a zero waste material, it also makes it a zero carbon material, because the drying process of that mortar absorbs carbon dioxide from the atmosphere. So we really find this is a kind of a full solution. Not only the individual units, but their joinery itself is looking at waste differently and contributing to better solutions for the environment. The tiles, incidentally, were recently installed in the facade of the Brighton Waste House, which is Europe's first permanent public building made almost entirely from materials thrown away or not wanted. You can look at Duncan Baker Brown's exhibition and installations here at the waste section of FutureBuild and find out more about that project as well. So in interior design, we're seeing an interest in making all kinds of components more sustainable and healthier as well, whether it's flooring, wall coverings, furniture, paints, and even artwork is being thought about differently right now. We think this project is really interesting, kind of versatile. We love it. It's called Biomarble. It's by a London-based designer called Hannah Elizabeth Jones. Hannah has worked, actually Hannah launched this project when she was at the Manchester School of Art. She worked with waste paper and turned it into this pitted, textured composite material. It has properties that are somewhere between paper and leather. And so far, she has managed to use it as a wall covering and as wall art. She's currently working on turning it into a hard veneer surface as well. The interesting thing about Biomarble in the current format that you've seen is that it uses the quilting techniques that you normally associate with textiles. So it's not just the outer covering of our products and of our accessories that are investing in using more sustainable materials. It's also the infills and the inner structures. So we see two examples here of products that have been used in the footwear industry, but are just as versatile and usable for us in architecture. On the left, we have a product from Enkev. They're natural insoles. So Enkev works with materials like coir and sisal to create very lightweight and comfortable insoles. And because they're natural materials like coconut, coir, sisal, they also have natural antibacterial properties. So they have a real advantage over synthetic alternatives that go into our footwear. On the right, we have a material called Bloom Foam. It's a spongy plant-based foam. And unlike polyurethane-based foams, the good news is that there is probably between 10 to 30% of this foam that comes from algal biomass. So that means, I don't know if you've seen the surfaces of rivers and ponds. There's a green collection of algae on top. That's actually a problem for rivers and ponds. If they've managed, I would say Bloom Foam has managed to harvest that problem. They extract it, they dry it out, and they turn it into this wonderful spongy material, which can actually be used for upholstery, for insulation, and obviously it's being used as a performance material for the footwear industry right now. So we can't leave the automotive industry far behind. It's definitely, the automotive industry is obviously opening up to exciting and new materials, both for the body of cars and the interiors or the upholstery. Some of the trends that are driving this need for using innovative materials are efficiency, consumer trends and awareness, and the end of life of these materials. One of the materials being explored for the interiors of cars is a material called Pinatex. You've probably heard of it recently. It's been used by a lot of footwear companies, also some interiors projects. Also near the South Bank Center, there's the first vegan hotel room. You should visit it. They have a lot of Pinatex upholstery and installations there. The interesting thing about Pinatex, we'd like to say, is it's a vegan material again. It's created from pineapple leaf waste, and this pineapple leaf waste is generated as a byproduct of pineapple production. So we've managed to generate a very versatile, strong material, a sustainable substitute to leather, and it's all from a byproduct of food production. So speaking of product design and the world of bioplastics that we're so fascinated with right now, Nuatan is a material from Crafting Plastic Studio. It's 100% oil-free and 100% compostable in a matter of weeks, actually, in a machine that they've developed. It's the result of a 6-year-long research project on bioplastics, and it's made with only renewable resources, making it 100% biodegradable. The good news is this material is very versatile. It can be cast, extruded, 3D printed, so you can create really, really complex geometry with this bioplastic, in addition to the fact that it can be composted in the right conditions in a matter of weeks. I think what we really love about this material is that it's, rather than shying away from this fast consumption, fast discard kind of culture that we're living in, it's actually embracing it. It's saying it's okay if we have sunglasses that we want to wear for a few weeks and then throw away. It's okay if we create them with bioplastics. So they have a really, I think they're offering a really smart response to the use and dispose culture that we're finding hard to change in people right now. And they have a really, I would say, a really smart response to the fast production and fast use cycles that we're seeing.
So then we come to infrastructure. Why would you use steel if you can have a greater strength to weight ratio and use a fraction of the material? And that's what polywood is. Polywood is an innovative discovery where they use wood composite mixed with a bioresin, and it's spun into these hollow tubes that are stronger than steel and use a fraction of the material. These poles are slated to replace solid electric poles in the north of UK. They're better for the environment, they're just as strong, and they use 85% less material than your standard electric poles. And actually, we have a sample of this in our library. It was too big to bring today, but you're welcome to come past. You can stand on it, and you can see exactly how strong it is. It's really amazing. And finally, we come to packaging. Packaging is a real problem now. Supermarkets are under fire because of their excess plastic on their fruit and veg, and we're looking for better solutions to this. So Lactips has come up with a great solution. It's a water-soluble, biodegradable thermoplastic that comes from milk protein. What's amazing about it is that it's a great substitute to oil-based plastic. It behaves the same way. It comes in pellets that can then be turned into films and any other kind of plastic application. But it can compost in 18 days in your home compost, and it will dissolve in water, hot and cold water, but it will leave no toxic residues in our environment. So we've got an example here of what it would look like, say, for a detergent pod. And then here's an example, if you get a chance to come up close, this has actually touched water, and you can see how it's dissolved. Also, it is food safe, so it's very useful for packaging for food. So let's look at some of the key themes that run through all of these innovations that we've been talking about. So first of all, we come to circularity. We've mentioned this before. We need to, as we look to the future, we need to shift our manufacturing models. We can't do the linear make, use, and dispose anymore because our landfills are filling up with waste and our resources are dwindling. We need to find better solutions. Architects, designers, innovators, they need to start thinking circularity when they start the creative process. And here are some of the key themes that they need to consider. So in designing for circularity, innovators, scientists, makers, architects, they need to look at the world with new eyes. Waste needs to be looked at something of value for our society and for our community. They also need to understand that whatever they produce, whether it's an environment, a building, a product, it doesn't exist in isolation. It's not alone, but it's a larger part of a big manufacturing network. It also exists in collaboration with other industries. All of us need to work together when we come to create new objects. And finally, the choice of material is very important when considering what you want to do with your product. How long do you want to make it last? The choice of material is essential.
So Adele mentioned waste-based design. We think this is a great example of a waste from the UK that has been transformed into a great material. So solid wool is a robust, versatile material created with herdwick wool from northern UK and bioresin. Now, in the north, the wool has been undervalued for many, many years now, and in the last couple of years has actually been sent to be burnt because they couldn't find a better use for it. The carpet making industry used it for a while, but that wasn't so successful as well. So this material has actually been, the wool itself has been sent to be burnt, and the reason is because it's hard, it's dry, it's a wiry wool, it's not really suitable for other kind of applications. So Justin and Hannah Floyd, who are the team behind Solid Wool, decided that they would transform it with a bioresin into a material with a unique aesthetic. You can see here, and Adele's going to hold up the material as well. It's got a beautiful woolly texture. It's a strong material. It's suitable for interior architecture, for countertops, for furniture, and yet it retains some of that beautiful grain that natural wool has to offer. So, as I said, the material can be cast into sheets. It can also be thermoformed and pressed into complex geometries and three-dimensional forms for product. And it's really a great example of how local waste has been transformed into a really beautiful and unique aesthetic. So one of the things we mentioned as a key trait of successful waste-based design is generating value where there was none. Now, nothing represents this more than ocean plastic. So this is a product that illustrates the concept well. It's a fabric called Sea by Diplug. And it's a flexible, versatile material made from plastic litter that washes up on ocean beaches and is collected from there. So Diplog actually partners up with an agency called U-Turn. Volunteers from this agency collect the ocean plastic. They spin the material into a yarn, and the yarn is combined with a softer fabric to create this very, very strong material. So it's useful as curtains in public spaces where you're going to experience a lot of wear and tear, a lot of traffic. It's used for upholstery. And interestingly, that very quality that makes plastic challenging for us, the fact that it lasts for so long, becomes an asset here because you've respun it into a really versatile, strong material, good for public spaces, good for architectural public use spaces. Something that we've noticed, if waste-based design has to move forward and really scale up in its production, creating symbiotic relationships is really crucial. We mentioned chipsport before when we talked about the Woolmark Trophy. And I think it's a great time to talk about them now. So chipsport is a new MDF substitute created from potato waste. The company incidentally partners with McCain, the frozen foods company that we know well. And in particular, why with McCain? Because McCain needs to dispose off of their potato waste. And for them, for Chipsport to scale up their production, they're able to source this potato waste from McCain and create a toxin-free material. The material, interestingly, is perfect for trade shows such as this. That's the use that they're suggesting for short-term applications, but also for architecture, furniture, interiors. It's a wonderful substitute, a toxin-free, formaldehyde-free substitute to traditional chipboard. Now, many of you may know about Ecor. It's a great material. It's both a material and a technology, actually. It's 100% bio-based and drawn from recycled materials. It's also 100% recyclable. It's a strong composite material that's made with only fiber waste. So that's fiber that comes from cardboard, paper, all kinds of household waste, but also agricultural waste. And the other ingredients are just water, pressure, and heat. That's it. No coatings, no toxins. So this sturdy and lightweight material is easy to decompose at the end of its life, which makes it a really ideal material for retail environments. Because retail environments, we've all seen shop windows, shop fittings, we're all working in that realm. It's a very fast-moving sphere. The lifetimes are really short. So Ecor is perfect for that because it has a very, very light footprint. It can also, interestingly, be developed to use local waste streams. So a client's company and their waste stream could be fed into creating Ecor sheets, and they can be decomposed easily at the end of their life. A wonderful example is Amsterdam Airport, where the weeds that grow on the side of the Amsterdam Airport runway were turned into the Ecor material, which is used in the airport itself. So really great kind of circular story there, and talking about life cycles. So while there are many definitions of biodesign and lots of different ways of defining it, biodesign is often defined as a combination of nature, science, and creativity, and biomaterials themselves sit at a unique intersection of biological sciences and design, poised for more sustainable innovation. So I thought I'd read out a quick quote from the curator and researcher William Myers here. He defines, the state of biodesign really well. So designers and artists have always looked to nature for inspiration and materials, but only recently have they been able to alter and incorporate living organisms in their work. In a world with finite resources and a growing population, design that mimics or appropriates the sustainable template of nature is likely to prove as vital as it is novel. So now let's look at this field in more detail.
So as Purva mentioned, biodesign is one of the most exciting and promising fields that is helping us address some of the key issues of our time. Designers are looking to nature to help and collaborate with living systems such as yeast, bacteria, algae, and mushroom mycelium to create cutting-edge materials. Biodesign explores the intersection of design and biological sciences as a catalyst for sustainable innovation. Biodesign integrates biomimicry, which is design inspired by how nature works that looks at life's engineering, and also biophilia, which replicates experiences of nature within the design, trying to reinforce that connection. And finally, it also integrates biodegradability and compostability, as they are key issues when we look at the end of life of our products. So new knowledge and experimentation of living systems, like we mentioned, algae, fungi, bacteria, or yeast, are beginning to offer extraordinary potential for future fabrication and manufacturing. We're learning how to harness the advantages of biological systems in terms of zero waste, the use of less energy, the use of less material, but also in how we biofabricate now like nature does. We are learning to program and engineer living organisms to grow tailored materials. And a great example is Magu that we've mentioned before. These tiles we showed you, they are cultivating mushroom mycelium to transform and bind agricultural byproducts into these wonderful natural materials that have high performance capacity. They're highly durable, but they're natural. They're 100% recyclable, compostable, and renewable. So it's a great experiment with living systems. And then this is a great example of biomimicry. We love this project. It's at the V&A. It's called Exhale, and it's the world's first living bionic chandelier by Julian Melchiori. This chandelier explores how advances in biotechnology and engineering can be applied to everyday objects and architecture to enhance our environment. This chandelier purifies the air in the room that it's in by creating photosynthesis that's performed by microalgae that is in those tiny leaves in there. Exhale is the first living object that continues to grow while it performs its biological-driven depuration formations. The light of the chandelier not only illuminates the room, but it activates the photosynthesis. It is also a great example of the symbiotic relationship between an object and a consumer. So the object releases pure oxygen for us, and then it takes in the carbon dioxide from the air, so helping create a more purified environment for us. And actually, he's also looking into experimenting using these leaves for facades and buildings. And here's another great example of biomimicry. This is called Plyskin, and it's the graduation project from the artist and designer Lindsay Kafsia. He wanted to look for an alternative for traditional building insulation, which traditionally is quite toxic. So he started experiment by looking at nature, and he started to imitate the fur of a polar bear, as we all know its great insulation properties. He started to experiment with recycled materials, bio-based materials, and 3D printing. So he created this prototype, and by studying how polar bear fur works with 3 layers of hair, he has created this great material, which not only is he looking at using for insulation, but he's also experimenting with the idea of using it as a facade. So in the future, we might have furry facades, so keep an eye out for that. And finally, we have compostability and fruit leather. Fruit leather comes from Rotterdam, and they create this amazing leather-like material that comes from all the waste fruit from the markets in Rotterdam. So all the fruit that isn't sold, the fruit that gets smushed in the process, the fruit that nobody wants to buy because it looks ugly, all of this goes into the production of this leather-like material. It's 100% fruit, and that means that it can be used as a product in fashion or upholstery, but then when you're done, it will biodegrade and compost into nature, and it will bring back nutrients to our environment.
All right, so the presence of greenery indoors, whether it's through living wall systems or dried products such as moss walls, is well known. There's a positive impact on occupiers through health and well-being. The added benefit with dried products such as moss walls, seen here, which are made with reindeer moss incidentally, is that they require little or no maintenance, which is a huge asset, no water or upkeep required, while still offering many of the same health and well-being benefits of biophilic design. So we really like this product from the Swedish company Nordogröna because they go one step further. Not only are they offering some of the benefits that traditional moss wall products have, they have a modular and pixelated system. So they have a velcroed back, which means you can attach them, detach them, you can grow the size of the moss wall, subtract it, adapt it really to the changing needs of the user and environment. So really a versatile and biophilic product here. Now let's look at sensory design. What is sensory design? Sensory design, or designing for the senses, recognizes that we understand and navigate the world with all 5 of our senses. It enhances awareness of the body and creates new emotional terrain through its simulation of our visceral responses. So clearly, materials play a really crucial role in sensory design, primarily in deciding what the impact of touch, taste, temperature, in addition to sight is. And materials are even more crucial today as we're trying to seek respite from a constantly growing digital world. The tactile experience of materials helps us disconnect from the overload of the virtual world and also enhances the experience of everyday products. Sensory design also paves the way for more accessible or inclusive design. So people who have more visual, hearing, or learning disabilities are able to really engage with products much better when design is more sensory and more conscious of its material choices. This is a really interesting example of how a textile can be elevated from something that's pleasing and functional to something that's truly sensory. So this is the work of textile designer and artificer Hannah Croft. She has a studio called Muna Matter. And she's invented a unique technique where crystals are directly grown into the structure of her fabric. So these can be embroidered or woven fabrics. And the hairier or the more fibrous the fabric, say mohair, which we all know, the better the growth of crystals. At the same time, while she's creating this beautiful sensory refractive sort of fabric, as you can see here, she's also challenging the idea of embellishment itself. Maybe embellishment doesn't have to be applied externally on a surface. It can be part of a structure. It can be grown into the structure of materials. So some interesting concepts here. In addition to being really sensory and inviting, the product incidentally is being used for interior wall surfaces, for bridal dresses, for set design, for movies. So quite interesting. So do you guys think concrete has to be gray or in neutral shades or plainer? Well, clearly Ivan Pohl, who's a Dutch designer, doesn't think so. He came up with this concept while he was at the Design Academy Eindhoven. It's called Happy Concrete. It's a wonderful textured, colored material. And when you look at it at the first time, you might think it's made out of a much softer material, something like sponge perhaps. So that is the effect he's going for, that you feel a softness and a kindness, a happiness, feelings that you normally don't associate with concrete. So really versatile. And there's been a wonderful response from the architecture and design industry. To the point where he's launched a company called Olasol, and these tiles are commercially available, really, I would say, easily available, short lead times, and they're shipping from the Netherlands easily for interior wall applications. Now, since its early discovery in 1992, we've all kind of been fascinated with the concept of transparent wood. In the period 2015 to 2016, there were actually two universities, one in Maryland and one in Sweden, that invested a great deal of time researching what transparent wood could look like and how it could be scaled up. But before that, let's talk about what is transparent wood. So it's a material with 90% transparency and even better mechanical properties than wood. It's biodegradable, which is something we expect from wood, and it's also shatterproof, which means it offers a significant advantage over plastic and acrylic and materials like that, which are normally associated with transparency. How is it created? It's created by stripping the lignin from wood and by injecting materials like epoxy or PMMA. And eventually, the real interest in transparent wood for us as architects, as building professionals, is that it can create novel structures such as load-bearing windows. So your windows could actually be made out of transparent wood, which would give us much better energy efficiency and heat loss because the wood would be the window. Aesthetically and sensorially, the effect is really pleasing because it combines two incredible feelings. One, the beautiful grain of wood, and two, the transparency that materials like acrylic and glass have. So really exciting. We'll all keep our eyes peeled for this technology scaling up soon.
And then we have Giles Miller's studio, which you might have already heard about. Giles Miller creates immersive experiences, surfaces, sculptures, and architecture that changes the way we interact with our surroundings. It makes it more enriching. The way their creative process works is that they start manipulating the relationship between materials and light. The characteristic aesthetic comes from the combination of technology with the handmade. The way they lay out these components is tactile, it's enriching, it's got depth, and it's got allure. You can see here some of their metallic finishes, but they also work with a range of materials like ceramics, wood, plastic, jesmonite, and they combine them in different ways and different shapes to create these immersive experiences. And then we've got buckskin. Buckskin is the result of two people who were, sorry, one sec. Buckskin is the result of two people who were worried about the amount of waste that was going in the shoe industry. They saw that 20% of the leather was going into waste. So they started exploring how they could use this leather and bring it back to the market. They started testing. It was a long journey, but they finally came up with this unique material. What they do is they break it down into granules. They add some latex, some pigments, and some other additives, and they roll it out into a sheet. This sheet can be laser cut, it can be laser printed, and it also can create these great curves that we've seen there. So it's very sensorial and tactile. What's interesting is that it looks a bit rough, but when you touch it, it's actually warm and soft. It also has a lot of properties that are very interesting, like it's stain resistant. It also is and it also is dirt resistant, and it offers great acoustic properties. It can be used for upholstery and for furniture and for flooring. And then we've got paper tiles. Paper tiles started out as well with the concern of what was going to waste in the local community. Paper tiles is created by the studio called Dear Human, that's based in Canada. They noticed that there was a lot of paper waste around their studio, so they started exploring what they could do with this as well. So they came up with these paper tiles that are in different shapes, hexagons, subtiles, rectangles. It is as hard as board, but it's actually as light as cork, and it is very versatile because it can be painted on and it can be printed on. So they encourage immersive experiences, customizable aesthetics, because you can combine the different designs and print on them the way you like to create your own experience. Also, what's very important is that it's got acoustic properties as well, so it can be also functional. But again, most importantly, it's 100% recycled post-consumer paper waste. So we've talked about health and well-being before. We've mentioned it. We've talked about the role of materials. But more and more studies are showing that building materials do directly influence the way we feel. So there's evidence that good planning can create a positive impact on our health and our well-being. We want to look at the materials that are supporting this. Actually, there was a great exhibition, I don't know if any of you got to see it, at the Welcome Gallery called Living with Buildings, and it explored the positive and the negative effects that buildings can have on the way we feel. So let's have a look at some of the materials that are playing a key role with this. Within the materials that are supporting health and well-being, we've divided it in two. So we've got materials that prevent unhealthy situations. Due to the very nature of their composition, they enhance a balanced environment. And on the other hand, we've got materials that are actively mitigating the effects of the toxic environment that we've already created. So let's have a look at these two types of materials.
What better way to contribute to the health of the environment and to human beings than by reducing the levels of carbon dioxide or toxins in the air? Now, Made of Air is a material we loved. It's a new biochar-based material, and it's a carbon-negative material. It consists of 90% of captured carbon dioxide combined with a biobinder. It's robust, it's flame-resistant, and it's positioning itself as a new substitute material for facade claddings, for interior architecture, and for furniture as well. So the starting point for Made of Air is actually waste biomass. So that's organic biomass of all kinds. When this biomass is burned in an oxygen-free environment, which is pyrolysis as we know, it creates a very dense form of carbon, a stable form of carbon, which when blended with a biobinder creates a very thermoplastic material that can be molded into beautiful hexagonal tiles like this. This is a project called, I guess it's a tile called Hexchar. A modular assembly of these tiles creates a really great facade assembly, and that's what they're currently testing out right now. The interesting thing about Made of Air is that it's compostable and it's non-polluting. So at the end of the life of these tiles, they can be shredded and sequestered into the earth, and this is an infinite loop. So this can be done innumerable times. Made of Air, crafted from captured carbon dioxide, and it's sequestered into the earth. So there's a genuine pathway for solving our larger problem of carbon dioxide through these tiles. Continuing our focus on atmospheric carbon, Air Ink is a pigment created from captured air pollution. So a company called Gravity Labs creates it. They have a contraption called CarLink. It's retrofitted onto the back of exhaust pipes for cars and for heavy machinery. And the soot and the toxins that are collected are turned into this dense pigment. They've obviously managed to scale it up quite a bit. They're rolling out spray paints, oil-based paints, and wonderful marker kits like this. We've got the whole set in our library. Come visit, but we have a small one up here. We'll show you here. And the interesting thing for you to know that 30 ml pen is the equivalent of 40 to 50 minutes of emissions from a car or machinery. So really interesting kind of new metric to think about carbon. again, thinking of our focus on indoor environments and carbon dioxide, many of you know that lime-based paint has always been purifying. Lime-based paint has been around for centuries and has always been good at absorbing toxins from the surrounding environment. With the addition of graphene, a super material, however, this paint becomes much stronger and much more long-lasting. An application of graphene stone and their paint called Biosphere, whether it's indoors or outdoors, makes these environments healthier. And the company actually launched a campaign called My Home is a Tree recently to indicate the really large impact that their products are having. Now, we've talked a great deal about the impact that plants can have. We talked about moss wall. We talked about how having the presence of green in indoor environments can make them healthier. But what happens when we don't have access to soil or sunlight? What are the other options we have available? So we really like this product from E-Concrete. It's a tile with a complex geometry and high porosity. And those two properties, the porosity of these tiles and their complex geometry, makes them a wonderful substrate for growing mosses and lichens automatically without much soil or sunlight. So really great as a solution to indoor landscape walls or facades where you don't really have the traditional resources for greenery such as soil. And it's in our library. Come have a look. Yep. Finally, thinking about the idea of performance, let's look at materials from the perspective of efficiency and longevity now.
So we all know wood. Wood has been used for millennia to build everything from furniture to homes to larger structures, but we rarely think of wood as something that is as strong as metals in construction. And yet, Liangbing Hu, a material researcher at the University of Maryland, has achieved this. In a simple, low-cost process, he has managed to compress wood into something that's stronger than steel and even some high-tech titanium alloys. So he's achieved this by a two-step process where he compresses the wood down and he creates a material that is 3 times more dense than the original wood. It is also 10 times stronger and more resistant to being ripped apart. And also, it is moisture resistant, scratch resistant, and impact resistant. So he's really creating a super material for the future for construction. Anyone who's been experimenting with biomaterials, who's trying to explore to recycle waste products or trying to create a bio-based material, knows how hard it is to create a bio-based resin or an adhesive. That it's hard to make them durable and it's hard to make them resistant. But Materialize X is achieving this. They're creating the first sustainable adhesive that is non-toxic, and they're aiming it to be used at the engineered wood industry. So this materials actually can be developed to have different stages of durability. It can last 2 days, 2 months, or much longer, depending on what you use it for. So for example, it could be used for a temporary installation outdoors. For example, a festival, they can create temporary flooring that can then just be left there after the festival and will just biodegrade into the earth. This is not only a material, they've also actually created a software that goes with it that uses machine learning to help these companies, the engineering wood companies and manufacturers, to find the best way to optimize the use of adhesive in their woods. And then there's Pluma by Aeropowder. So this is the first thermal packaging made from surplus feathers. These are chicken feathers that are in there. They're encased in a bioplastic, and it is the first thermal packaging that uses that. It is great when you need to protect something that needs to be transported and you need to keep the temperature regulated, for example, food. So this could be a great use for that. Also, it is a symbiotic relationship with the food industry, because actually chicken feathers are a huge problem that they don't know what to do with it. It creates, when they're put into the land, it's acidic and it pollutes our soils. So actually this is a great use where they've reused it into packaging. And finally, we have these responsive facades. These facades are a research collaboration from Newcastle University. It's between the schools of engineering and the architecture, planning, and landscape schools. Together, they've come up with this low-cost way of creating, with low-tech, a responsive facade to climate. So basically, if you look at these panels here, you can see when it's dry, the panels open, and when it rains, they will close. So it'll create an energy-efficient facade for a building. But it's using low-tech. It's inspired on the way a pine cone reacts. So by putting together, laminating 2 different types of wood veneers that react to humidity at different speeds, they create that capacity. What's also interesting with this low-tech technology is they've been able to develop very interesting aesthetics by playing with the studs or the different effects of the adhesives when they put the wood veneers together. So it's a really exciting project. So to conclude, I guess it's clear that we're passionate about materials and we think that they are amazing for our future, but it's not only us.
So just as a concluding note, we found this, we really love this quote, and the fact that this summit existed in 2017, The Economist had a Future of Materials Summit, and you'll notice that they really put materials and their impact on manufacturing even above innovations like 3D printing and robotics, which I think is really symbolic of the movement that we're all part of. But yeah, this is how we feel about materials. We're happy to, I think we have possibly about 15 minutes to answer any questions you have, or if you guys would rather just come and have a look at the materials, feel free to do that. We have labels for all of them. You can also take pictures.
And feel free to visit us at our library.
Exactly. Feel free to visit us. If you don't have time right now, feel free to visit us at the building center where the library is. We're happy to answer all your questions there as well. And yeah, thanks so much, guys. Thank you.
Any questions?
Joe has a mic over there.
Or if you just want to come up and look at the materials.
Hiya, thank you. That was a really interesting, very informative talk.
Thank you.
So many materials to take in. So as a consultancy, do you work with the material makers to think about design applications? Is that something that you do?
Absolutely.
Yeah, so we both have a background in design. I come from fashion and Purva as an architect, so we do help them develop products with their materials.
Yeah. I think we find sometimes, we notice this a lot, there'll be people who come with a great material but they don't have an application in mind. Sometimes it's the reverse, there's an application but the material is still evolving, and I think that's where we come in. It's our goal to really pair them with a strategic project or use our expertise and network to advance the product itself, so the idea itself. Yeah.
And do you ever think about terms of scale? Is that something that you also consider?
Yes, so that is a huge problem for a lot of the material makers we work with, because a lot of them have explored and innovated in their houses and their kitchen ovens. So they've got a great material, they don't know how to scale it up, and that's something that we help them with. We try to partner them up with bigger manufacturers.
Yeah. Or even other research possibilities where they can access the infrastructure that they need. Yep. Any other questions, guys? Any questions? Oh, there's one over there.
Thank you so much. It was very nice lecture. I heard that there was a bio-based resin, that it's a kind of adhesive. You said that maybe it would last for hours, I don't know, for months. I was not here from the beginning of your presentation, unfortunately, but I'd like to know that is there anything that doesn't produce any CO2 or anything that it is eco-friendly that can be substituted to the urea formaldehyde, mostly that is used in MDFs?
So I guess this would be one of the possibilities, Materialize X. It's not in the market just yet, but that I think would be the strongest contender. There's other versions, but a lot of the material makers are protecting their IP as well as they develop their bioresins.
I think we're hearing a lot of starch-based adhesives, because natural starch-based adhesives have the ability to, not have that toxic impact that things like urea formaldehyde, as you mentioned. But specifically as a product where someone is calling that adhesive by something, I think I agree with Adele. It's the Materialize X. That's an interesting material to look at.
Okay, thank you so much.
Thank you.